In this video, we'll take a look at section 8.5, which is natural logarithmic functions. Now, our first objective is find logarithms with base e using a calculator. Now, a natural logarithm is a logarithm of the form f of x equal to log base e of x. So what makes this log function different is our base is e. Now, the way that we write natural logarithms is log base e of x. This is just equal to ln of x. Okay, so when your log has base e, the way that you'll see it written out is ln of x. Now, e, this is just a number just like pi. So pi we approximate as 3.14 and 15, and that just keeps going on forever. E is approximately equal to 2.71828182884, and this decimal just keeps going on forever. So e is just a number. It's approximately 2.718. Now, properties of natural logarithms. We have ln of 1. This is equal to 0. Also, ln of e. This is equal to 1. Now, natural log is one of the logs that you have on your calculator. So the first button on your calculator, it says log, L-O-G. This is when your log is base 10, which is what we saw in the previous section. ln is also on your calculator. This means you have a log of base e. So now for this example, it says find the natural logarithm to 4 decimal places. So you have ln, so you have natural log of 78,235.4. So using our calculator, we're going to plug this in and get an approximation. So you press the ln button on your calculator, and then we'll type in 78,235.4. And then we're rounding it to 4 decimal places. So we have 11.2675. And this is our approximation for a natural log of 78,235.4. Next one. So same type of problem. This time we have natural log of 0.0000309. So plugging this into our calculator, this is approximately equal to we get negative 10.3848. So the only 2 logs that we have on our calculator is just the regular log, which is base 10, and then natural log, which is base e. Any other base we cannot put into our calculator. So this leads us to our next objective. This is changing logarithm bases. So we could actually change the base of our logarithm using this formula. So we have the change of base formula, which states for any logarithm bases a and b, and any positive number m, log base b of m is equal to log base a of m divided by log base a of b. Now, the 2 bases that you would want to change into is the ones that you have on your calculator. That way you could get an approximation. So you really want to change this into either log of m over log of b, so that way our base is 10, or natural log of m over natural log of b. You could use either one of these formulas, and it'll give you the correct approximation. So for our first example, find log base 6 of 7 using common logarithms. Okay, so we want to change this to either base 10 or base e. Okay, so log base 6 of 7, let's go ahead and change it to base 10. This would be log of 7 divided by log of 6. because our original expression, log base 6 of 7, we can't put this into our calculator. There isn't a button for it. So what we have to do is change it to base 10 or base e. So I'm going to go ahead and use base e here, and we'll round this to, say, 4 decimal places again. So we have log of 7 divided by log of 6. Okay. This gives us 1.086. If we rounded it to 4 decimal places, this would be a 0 as well. Now, next example, find log base 6 of 7 using natural logarithms. So for the previous example, yeah, we actually had to use base 10. Now, with natural logarithms, okay, so log base 6 of 7, let's see if we get the same answer. So this would be natural log of 7 divided by natural log of 6. And if we put that into our calculator, let's see what we get. So we actually get the same exact answer. We get 1.0860. So it doesn't matter if you change it to base 10 or if you change it to base e. So if you did the common log with base 10 or the natural log with base e, you're still going to get the same approximation. So that was it for section 8.5. If you have any questions, don't hesitate. Just email me and I'll help you out.